So why is integration going to give us the area bounded by the graph? Okay. So if you look at this diagram, y equals to fx, so that's the generic function. And the blue shaded part is basically the area bounded by the graph and the x-axis. Okay, and whatever x is, right? So x can be any real number, 2, 3, 4, 10, or whatsoever. I'm going to assign a function. Let's call it the area function for this shaded area. Okay, and let's call that ax. Okay, so like I said, different values of x would give us different areas, right? Bounded by the curve and the x-axis, and of course, whatever x is. Okay, so let us draw a little rectangle here. So I'm going to extend this a little bit. Okay, so let's say, okay, something like that. Okay, and the width of this rectangle is h. Okay, so if you think about it, the width is h. Now I'm going to draw another rectangle, maybe a little bit smaller than that, as you will see. Okay. So slowly you'll get a hang of it. Hope you see where I'm going. Okay, so now the area of x plus h minus ax, okay, which is basically this area, right? So a of x plus h minus ax is going to give us the black shaded area. Okay, I'm going to erase that so it doesn't confuse you. So this area would be smaller than the area of the larger rectangle, right? So you can see that there's a larger rectangle here. Okay, so what is the area of that larger rectangle? Right, the area of that rectangle would be the width times the height, right? The width is h, and the height is basically f of x plus h, right? So this is the height. This is the height of the larger rectangle, right? So this is f of x plus h. Okay, so width times height. And at the same time, this area is going to be larger than the smaller rectangle, right? So you can see that this is the smaller rectangle. And what is the area of that rectangle, right? It is width times height. And the height of that is fx. Okay, so I hope you can see that, right? So this is the height, right? This is the height of the smaller rectangle. And I hope you can see why that is fx. Okay. All right, so now we have this nice inequality. I'm going to divide everything by h. So if you divide everything by h, fx is less than a of x plus h minus ax over h, and that is less than f of x plus h. Okay, so let me write this nicely. Okay, so what are we trying to do here, right? So I'm going to find the limit of this whole inequality as h approaches 0. Okay, so I'm going to let h approach 0, right? As you can see, if I let h approach 0, I'm going to get the blue area, right? Which is the area that we're trying to find. So if I let h approach 0, okay, what does that give us? Okay, so all right, so we have this nice inequality, right, where h is going to approach 0. Okay, so if you look at this middle part, this is actually dA dx. Okay, and left-hand side, well, nothing much is going to change. And as for the right-hand side, when you let h approach 0, then this is basically just, oh, sorry, I forgot to exclude the limit. Okay, so there we have it. And for the right-hand side, this is basically f of x, right? Because h is going to approach 0. So dA dx is less than fx and greater than fx. So in other words, dA dx is equals to fx, right? And what is a, right? To get a, we integrate both sides with respect to x. So ax, right? So remember, a is our area function here. So ax is the integral of fx dx. Okay. Now, let's say you want to find the area of this region. All right. So I'm going to draw this region. Okay. Let me choose a different color. It's not that many colors. Okay. Let's use this. I hope you can see the difference. All right. So let's say this is B, and let's say this is A. Okay. And now we want to find the area here. Okay, so what do we do? Well, this is basically A of B minus A of A. Okay, I hope that doesn't confuse you. This A is basically, the X value here, right? Not the function. So A of B minus A of A, right? So that will give us the area, which I just shaded, right? The green area here. And what is that equal to? Okay. So if you recall, ax is the integral of fx, right? And the integral of fx is, well, I use a capital letter to denote this, right? So this is the integral of fx. Okay, this is a big F, right? Okay, so now to get this area, well, basically, we have to integrate from B to A, right? Okay, maybe I should write it this way. Okay, so this is basically a F B minus F A, right? And what is that? Okay, our definite integral tells us that this is actually the integral of fx from B to A. Okay, so that's the motivation and hopefully the essence. You can understand why integrating gives us the area bounded by the curve and the x-axis.